All right, case one. This is where you have a denominator that factors into linear factors. So this example here, for a while, I'm going to pull the integrand out and we're going to work on it individually. So we've got x over x squared plus 3x plus 2. Well, what I want to do is I want to break that up. Well, first I want to factor this. X plus 1 and x plus 2. You get that. And now what I want to do is break this into two partial fractions. I want to break this into a over x plus 1 plus b over x plus 2. And we've got to solve for what that a and b are. Now, if you've never seen something like this before, it might look a little strange. What we're going to do really is we're going to take this and we're going to solve this for a and b. So here's how you do that. You take the full equation there, x, this is the first one, so I'm going to write it out all the steps. X plus 1, x plus 2 equals a over x plus 1, skip some space, plus b over x plus 2. And now what I'm going to do is multiply everything through by this denominator over here. So I'm going to multiply everything by x plus 1, x plus 2. And now I'm going to cancel everything. Notice, actually I'm not going to, well, I will. Over here, both of these cancel with both of those. Over here, the x plus 1 cancels with the x plus 1, and the x plus 2 cancels with the x plus 2. So what we're left with is, from this side, we've just got x. And over here, this gives me a times x plus 2. And the other one gives me b times x plus 1. So now this is the thing we've got to solve for a and b. Now there are a couple of different ways we can do this. One way, and this is not the fastest way, but it is the way that works all the time. So let's look at it. On this side over here, we've got we've got 1x plus 0. Over here, I'm going to distribute my a and b through there. So I get ax plus 2a plus bx plus 1. Plus 1b. And so if I sort my a's, or I'm sorry, if I sort my x's together, I've got a plus b times x plus 2a plus b. All right, so if this is equal to that, then what has to be true is the coefficient of x over here has to be equal to the coefficient of x over here. And then the constant term over here, and I'm calling it a constant term because it doesn't have an x on it, that has to be equal to the constant term over here. So what I can get out of this is a plus b equals 1. And then 2a plus b is equal to 0. All right, now I need to solve this, so I'm gonna subtract. This is just a system of two equations and two variables. If I subtract this, I get a minus 2a is negative a, b minus b is 0, 1 minus 0 is 1. So what I get here is a equals negative 1, and so b is got to be 2. Is that right? If a is negative 1, then b is 2. Yeah. So there's a lot of algebra in this, but This is going to allow us to rewrite the integral. So I've got a is -1 and b is 2. So if I come back up here and look at this, I can replace that a and b there. And so my integral becomes integral of -1 over x plus 1 plus 2 over x plus 2. And now this integral is easy. This first one is just -1 natural log of x plus 1 plus 2 natural log of x plus 2 plus c. And that's it. So there's a lot of algebra going on, but it helps us turn a somewhat complicated integral into an easier one to deal with. All right, let's do another example. 2x plus 1 over x squared plus 2x minus 35. So first up, how can we factor that? X squared plus 2x minus 35, that's going to be x plus 7 and x minus 5. All right, so I'm going to rewrite this as 2x plus 1 over x plus 7, x minus 5. And I'm going to again split this into x plus 7 and x minus 5. Put an a and a b up here. All right. Now I'm going to multiply. This time I'm not going to write everything out. I'm just going to say, let's multiply everything by x plus 7 and x minus 5. And after the cancellation stuff, you wind up with 2x plus 1 equals a times x minus 5 plus b times x plus 7. All right, so once we've got that, let's see, the coefficient of, well, I'll distribute this out. You get ax minus 5a plus bx plus 7b equals 2x plus 1. So if we look at the coefficient of x, over here it's 2, over here it's going to be a plus b. So you get 2 equals a plus b. Let me write that the other way. A plus b equals 2. And then from the constant, you've got 1 equals minus 5a plus 7b. And so we've got to solve these two equations. Let's see, let's multiply that top equation by 5. And that's going to give me 5a plus 5b equals 10. We've got minus 5a plus 7b equals 1. So we wind up with 12b equals 11 if we add those up. Yeah, so b is 11 over 12. And then to get a, I'm just going to plug back into this equation here. A plus 11 over 12 equals 2. 2 is 24 over 12. So a has got to be 13 over 12. All right, so I can rewrite my integral. Actually, I'm going to put all this in a box because this is all my partial fraction bits. So I can rewrite my integral now as integral of, and I'm referring back to this up here. A is 13 over 12. X plus 7. And then B was 11 over 12 over x plus 7. And I'm going to make my integral symbol bigger. So integrating this now is just 13 over 12 ln of x plus 7 plus 11 over 12 ln of x plus, I miscopied that. That was supposed to be x minus 5. Plus c. And so that's my answer. All right, now there is a quicker way to do this. This example up here, once we get this equation here, this is sort of an alternate technique. Once we get this equation, what we can do is plug in the numbers that make the various terms 0. Like if I plug in x equals 5, it'll zero this out. And if I plug in x equals -7, it'll zero this out. So let me show you how to do that. If I plug in x equals 5, then I get, let's see, we're plugging it in over here. So this is going to give me 2 times 5 plus 1 is 11 equals 0 plus b times 5 plus 7 is 12. So that gives me immediately b is 11 over 12. And then plug in x equals -7. Over here, that's going to be -7 times 2 is -14 plus 1 is -13. Plugging in here is going to give me a times -12. And this, of course, is 0. So you get a equals 13 over 12. So that's another technique you can use. And they'll both get you the correct answer. Let's see. We've got one more example, but we'll put that in the next video.